Okay, so today your worksheet is this, the apply section on angles and polygons. It's tricky enough, some of it, so what I'm going to do is I'm just going to get you started on some of the questions so as you know you aren't getting stuck from the get-go. So let's have a look at question 1. In each diagram below, two regular polygons are shown. Calculate x. So x is just like this wee missing angle here. I'm going to zoom in here for you, okay? So if you want to find this wee angle here, the best way of doing it, what I would recommend doing, is find the size of this angle and find the size of this angle. And if you can find these two, well then the whole thing would add up to 360. Okay, so that should be straightforward enough. Okay. Next question. Shown as a regular pentagon, find y. Right, so there's a pentagon, so we should be able to find each of these angles here. Okay, forget about the line, we should be able to find each of these. Okay, most importantly, this one. Okay, now we've got a triangle here. Now this is a regular pentagon, which means that all the sides are the same. So if this side is the same as that side, I want you to think about what type of triangle that would be. Okay, and if you know what type of triangle it is, you should be able to find these two. A regular polygon has 18 sides. Calculate the size of each interior angle. Well, that's just going to be using the formula that I would have shown you in the first day, or Miss Humes taught you in the second day of this, okay? N minus 2 times 180. And that finds all the angles. So if you know how to find all the angles, what size is each one? Question 4 is the same. Explain why this cannot be an interior angle from regular polygons. So regular polygons is whenever all the angles are the same. I would start this one off by continuing this line out, okay, and finding this exterior angle. Okay, once you know what the exterior angle is, I want you to think about the fact that exterior angles add up to 360 degrees. And all I want you to do is tell me, if this is the exterior angle and they add up to 360, how many sides are there on the shape? Okay, so how many sides are there in that shape? And that should give you a clue as to why it's not an interior angle or a regular polygon. A polygon has an interior angle that is 5 times larger than its exterior angle. How many sides does it have? Okay, so here we go. We'll start drawing a regular polygon. And so we'll keep going on like so. Here's the exterior angle. And here's the interior angle. Okay? So this here is 5 times larger than this one here. Okay, I don't really want to talk too much more about it. I want you to have a sort of a go at it yourselves. Explain why regular hexagons tessellate. Okay, so to tessellate means like this. I'm going to show you an example of. So squares tessellate nicely. Just means you can put them together and there's no gaps. Okay. Regular triangles, so equilateral triangles, they'll tessellate quite nicely, like so. Okay, and they can just go on and on forever. So your question is, explain why regular hexagons tessellate. So your hint here is think about what size each of these angles are and what they add up to. Same for the square. What do these angles add up to? So using that information, you want to explain why regular hexagons tessellate and why regular pentagons do not tessellate. That should be enough to get you go on in that worksheet, okay? It is tricky enough in some parts, okay? So just try your best. Okay, see you now, have a good day.